Okay, so there's some things that happen when resistance is involved in a circuit, which has to be. There has to be resistance in the circuit. Voltage always drops as current flows through a resistance, right? So let's think about this for a second. You're walking down the street. All of a sudden you find yourself shoving through a big pool of chocolate pudding. Can you maintain your speed? No, you slow down. You don't have enough oomph, right? So anytime voltage goes through it, it sucks some of it out. An increase in resistance causes a decrease in current. All right, so let me tell you about the impact of resistance on a circuit. Voltage always drops as current flows through a resistance. When we have a circuit, one side is battery voltage, the other side is ground. Once voltage flows through a resistor, it's going to use all the voltage, and it's going to be zero at the end. Therefore, voltage always drops as it flows through a resistance. An increase in resistance causes a decrease in current. Let's say you're walking down the street, and I don't know, you find yourself all of a sudden pushing through a pool of chocolate pudding. I think you're going to slow down. Thus, we can see that when resistance increases, current decreases. All resistances change the electrical energy into heat energy to some extent. Anybody ever here change a light bulb after it was just on? Right? Maybe you change one in your house, maybe you did it on the car, but would you say that that light bulb is hot? Okay, that light bulb is resistance. I think that's all the proof you need. What I would do in the classroom is I would take a resistor and run current through it, and then have somebody come up and touch it. What's funny is your skin absorbs some of that heat before you feel it. So you get into the fake sense of security and hold your finger against it, and then it gets hot really fast. Okay, so this is showing the measurement of voltage drop. We're going to be learning how to use meters, and I'm going to show you in the videos, and I'll show you what voltage drop is. But when we're looking at a meter, voltage drop is nothing more than comparing 2 points. We take a meter, we set it on volts, and we touch the probe to things. If we're on this side of a circuit and 12 volts is leaving a battery, then when I'm connected to this point here, I better have 12 volts there. If I don't, there's something wrong in that wire. Well, if I'm measuring the difference of 2 points, what would that show? 12 volts on one side, 12 volts on the other. It would show zero, a difference of 0. If I'm at a load, right, this side is ground. This is 0 volts on this side, and this side is 12 volts. So now if I test this point to this point, I have 12 volts on this side. I have 0 volts on this side. What's the difference of those 2 points? It is 12. Okay, 12 volts difference. Here we have a switch. It's on the ground side of the circuit. A switch should never, ever add resistance to a circuit. But if I check both sides, 0 on this side, 0 on this side, what's the difference between that? 0. Okay? Okay, so let's look at some rules that regulate current flow. Electrons repel each other. Electrons are both negative. So when a negative electron comes up to another electron, that electron beats it. Like charges repel each other, right? Positive to positive pushes away. Negative to negative pushes away. Just like 2 norths on a magnet, 2 souths on a magnet. Unlike charges attract each other. So with magnets, right, a north is attracted to a south, and a positive is attracted to a negative, and vice versa. Electrons flow in a conductor only when affected by electromotive force. Okay, so that means that until a voltage is applied to a circuit, nothing moves. But there has to be something else that goes along with it. A voltage difference is created in the conductor when electromotive force is acting on a conductor. We need two different current flows to what? But if you remember, current flows from a positive point to a less positive point. So once we apply voltage, the other side of that circuit needs to be a lower voltage, and then electrons will move as soon as we apply an electromotive force to it. Electrons flow only when voltage difference exists between 2 points in a conductor. That is what I just said. If you remember, electrons flow from a positive to a less positive. Therefore, there has to be a difference between the 2 points for it to flow. Current flows to ground in an electrical circuit. Right? And that's what the conventional theory says, that current flows from a positive to a less positive. Ground is our lowest. We had a conversation about that when we talked about jumper cables. Ground is defined as the common negative connection of the electrical system and the point of lowest voltage. The negative side of the battery is 0 volts. That is connected to the metal of the vehicle. Therefore, all the metal in the vehicle is a pathway back to ground, and that is the common negative that we're talking